look at the zeros of a polynomial function and what they can tell us. The zero of a function is just another word for the x-intercept. In order to find the zeros of a function, we just need to set f of x equal to 0 and solve the resulting equation. This is where it gets its name, because we're just setting the function equal to 0. As an example, let's consider the function f of x equal to x squared plus 8x plus 12, and we want to find the zeros of this function. So we have the equation 0 equal to x squared plus 8x plus 12. Since this is a quadratic, we need to factor. We need two numbers that multiply to be 12 and add to be 8. We can achieve this with 6 and 2, so we have x plus 6 times x plus 2. We then set each of these pieces equal to 0 and solve. X plus 6 equal to 0 gives us a 0 of negative 6, and x plus 2 equal to 0 gives us a 0 of negative 2. So this function has two zeros, negative 6 and negative 2. Each zero of a polynomial function also has a multiplicity. The multiplicity of a zero is the number of times that zero appears in the factorization. In order to explain that, let's consider this function x plus 3 squared times x minus 1 cubed times x plus 7. In this case, there are three zeros. Negative 3, 1, and negative 7. The x plus 3 part gives us a 0 of negative 3, the x minus 1 part gives us a 0 of 1, and the x plus 7 part gives us a 0 of negative 7. And now each of these has a multiplicity. For the x plus 3 part, this appears twice in our polynomial because we have the x plus 3 squared. So this multiplicity is 2. The x minus 1 part of this function is cubed. That means it appears 3 times. So its multiplicity is 3. And x plus 7 only appears once. So its multiplicity is 1. The multiplicity of a 0 can also tell us what's happening with the graph around that point. If the 0 has a multiplicity of 1, the graph will just cross the axis at that point. For a multiplicity of 2, the graph will actually come down, touch the x-axis, and then turn back around. A multiplicity of 3 also crosses it, but it kind of smooths out right around that point and then goes back to increasing. Let's consider this graph here. This 0 right here touches the x-axis and turns around, so it has a multiplicity of 2. This one crosses almost like a line, so that's a multiplicity of 1. And this one crosses, but does kind of flatten out around the axis, which makes it have a multiplicity of 3.